spaces. It is my pleasure to welcome you all for the first session of the learning series, One Brick at a Time. The first session is on designing net zero buildings, basics and approach. All of this series is part of the business charter, which is on value chain approach to decarbonize the building and construction sector of India. This charter was launched in February 2022 and was endorsed by Mr. Anand Mahindra. We presently have 18 signatories on board who have signed up to this charter and who are also committed to the net zero ambitious targets to their business strategies. So to commence the first session on designing net zero buildings basics and approach, I would first like to introduce you all to the expert speakers that we have. I hope all the participants are able to join through the join with computer audio mode. You can all pose your questions in the Q&A box that is there on the bottom of your screen, bottom center of your screen. For any other questions, you may reach out to us, and this event will also be recorded and will be posted online for your convenience. So to begin our session, we would first like to introduce to our expert speaker. I'll first begin with architect Saswati Chaitya, who is an associate director at GKSPL, which is a research and advisory firm working on energy efficiency in buildings, resource efficiency in the production of building materials and deployment of decentralized renewable energy systems. She is an architect and environmental planner by training and has over 15 years of experience working as an architect, green building consultant, and building energy efficiency expert. She has managed the Indo-Swiss Building Energy Efficiency Project since 2012 and was part of the core team that developed Eco-Nivas Samhita 2018, which is part of the WEE PET policies. The second speaker and our eminent panelist is architect Tanmay Tathagat, who is executive director at Environmental Design Solutions. Mr. Tathagat works on projects dealing with sustainable development, building energy efficiency, green buildings, and energy efficiency standards, and labeling in Asia, Africa, and the US. He leads EDS team of experts working on climate change policies, energy efficient building design, building code development, energy simulation, and green building certification. He led the ECBC development in India and has been working with public sector construction agencies and municipalities on green affordable housing as part of the government scheme for housing for all. His current work is focused on fostering an integrated vision for grid interactive net zero buildings and communities, especially in the tropical climates as part of the low carbon development model. Our third most eminent speaker and the panelist is Dr. Sunita Purushottam, who is the head of sustainability at Mahindra Life Spaces Developers Limited. Dr. Purushottam has over 20 years of sustainability strategy and environmental consultancy experience in the areas of environmental impact assessment, air pollution modeling, and methodology for GHG emissions inventory and carbon offsets, including carbon neutrality strategy, waste management strategies, and water risk technology solutions for sustainability and for various corporate social responsibility initiatives. She is also the member of Mahindra and Mahindra CSR Council, member of Mahindra and Mahindra Sustainability Council, also a working group member, digitalization of workstream for built environment, World Business Council of Sustainable Development, working group member of Building System Carbon Framework, World Business Council of Sustainable Development, and Fellow of Royal Met Society in London. We also welcome, who will be joining us shortly, Dr. Bhaskar Natarajan, who is the Director of Programs at AEEE Delhi. Dr. Bhaskar has over 25 years of experience in areas related to clean energy efficiency, sustainable development. Dr. Bhaskar has managed large programs working with the donor agencies to scope out program goals and working with multiple stakeholders to deliver the results. Dr. Bhaskar has worked on projects supported by the World Bank, USAID, ADB, UNDP, CIDA, and DFID, amongst many others, and has been a part of several official government and industrial committees for energy and environment. Dr. Bhaskar has worked with the agencies, with the Ministry of Power and Ministry of Environment, Forest and Climate Change as well, on various national and subnational programs for energy efficiency, and sustainability. Lastly, I would also like to introduce myself. I am Niyati Gupta, who is a senior program associate in WRI India. I work with the climate team, and I have a background in climate resilience and climate responsive design, both at the building and at the city level. I am presently working with the climate program where we are working towards the just transition aspects and climate resilience aspects for MSMEs in India. I would also like to introduce my colleagues, Mr. Subrata Chakrabarti and Ms. Priyal Shah, who are Senior Manager and Senior Program Associate, respectively, for the climate program. They have diverse background while working on technical review of GHG estimates and methodologies for key economic sectors, and also on setting of SBT criteria for the Indian companies. So with this, I would also like to take you through the agenda for this particular session. This entire program is divided in 4 parts. First, we want to apprise all the attendees and to the esteemed panelists regarding the business charter for which all this series is associated with. After the introduction to the business charter, we will move on to the first presentation on climate responsive design and approach to design of net zero buildings, which will be led by architect Saswati Chaitya, and followed by the conversation on business case for net zero and introduction to buildings in context for Mahindra Lifespace Developers Limited. This will be led by Dr. Sunita Purushottam and architect Tanmay Tathagar. And lastly, we'll be taking up the Q&A that you will be posting in your chat box, and we will try to cater to as many questions as we can given the brevity of time, and we will close the session. So to begin the session, we will first start with the introduction to the business charter, where it all began, which is on value chain approach to decarbonizing the building and construction sector of India. So here, in this context, I would like to highlight few points at which this particular project was conceived. It was particularly India witnessed the USD 26 billions of FDI inflow in financial year 2021. The country also expected to become the third largest construction market by 2022, with an infusion of $1.4 trillion on infrastructure projects particularly. This was through all national infrastructure pipeline. The real estate industry in India also expected to reach about $1 trillion by 2030 and contributed to about 13% of India's GDP, as the sector has seen an increase by 8% increase in the CAGR by the financial year estimates of 2021. So despite the current economic state of play, this particular sector, which is the building and construction sector, has also seen an alarming set of environmental challenges, which also includes about 25% of carbon emissions, which is nearly about, now it has become nearly about 28% of the national average of the air pollution that we see, particularly in case of India. The electricity consumption has also tripled over the past. This, if we see the energy outlook report of 2021, where the energy demand is also expected to increase further by 50% by 2040. So along with this background, there are two things. One, there is a key trend of predominance of urban growth or the urban sprawl or urbanization, so to say. And this will lead to growing emissions in this particular sector. Another, from the demand side, if we look at it, it is as per the India Energy Outlook for 2021, if we see, India is yet to build about 50 billion square meters of residential floor space in the next 20 years. And this particular share of the floor space or the concrete space is going to reach by 60% in 2040, as opposed to 45% in 2019. So it is to say that there's a significant increase in the per square foot area with the rapid urbanization which is going on. So what does it all mean? So this means that there is going to be a massive use of building materials. There's going to be a significantly higher energy demand and multifold increase in the emissions. So these are the three major aspects and the three major challenges which we face at the environmentally from this particular sector alone. So here, the opportunity that lies before us is that we act now to ensure that our economic growth is sustainable, while also considering the risk associated with the businesses in this sector are not disturbed. Hence, this particular charter forms an evidence spine and the backbone of our initiative, in which our theory of change can be looked at into a holistic value chain approach. So, going through the process of how exactly this charter was formulated, this was particularly a 3-point strategy that we adopted, where all the partners in this particular partners of this charter came along, and together they conceptualized the business charter for decarbonizing building and construction industry in India. We realized that this sector has multiple number of players, and also this particular sector is fragmented. So hence value chain was adopted because of this fragmentation and multifaceted players that we have. So we began by engaging with diverse set of 150 plus stakeholders, which included engineers, energy modelers, developers, construction companies, manufacturers, vendors, architects, planners, designers, civil engineers, and various kind of MEP consultants, industry bodies, rating agencies, institutes, and policymakers. So with this diverse group of 150 stakeholders, we hosted various stakeholder consultation in 2021. So out of the 4 consultations that we had, the specific themes that we went ahead with was designing net zero buildings, construction and operations, occupies perspective, and material efficiency. So these were the 4 themes that we went ahead with the 150 plus stakeholders. And the idea was to invite diverse perspectives where all these stakeholders were involved in. This also helped us understanding the challenges and opportunities throughout the building life cycle. These dialogues helped us shape 6 broad categories of the priority action that we will discuss in the next slide. And this is how the charter was launched in the year 2022. So this was an effort from 21 to 22, where the priority actions were then identified. So the 6 priority actions that we have is design net zero buildings, based on which we have now our first session on. So this was, so here net zero buildings required a special focus in building layout, design of the buildings, and utilizing low carbon alternate materials, all of which contributed to design of net zero buildings per se. It was also identified that there is a need for architects, designers, engineers, and others to be more aware about the design methods, construction tech, and building materials, which can be incorporated well at the design stage itself before the execution. The second priority action was aligned with the climate science, in which the signatories committed to adopting science-based targets and work across the value chain to build resilience to the future climate risks. They also committed to adopt design guidelines that result in lower energy consumption during the operations. As we move on to the third priority action, we understood that 40% of the emissions are coming through the building's operational phase. Hence, the third action is focused on improving operational efficiency, where companies were requested to commit to increase energy productivity to maximize the saving during construction and post-occupancy for residential and commercial buildings particularly. The fourth action is on improving material efficiency, as it was said that it was reduce the negative social and environmental impact caused by the input of the materials that are being used. So here the companies were set to adopt technological solution and mainstream alternate and low carbon materials to minimize emissions during the construction and operational phase of the building. As part of the fifth action plan, the institutional mandates and handholding were important for mainstreaming climate actions in this sector. Hence, action 5, this particular action is focused on assisting in updating and the curriculum of colleges, professionals, and the workforce for sustainable construction practices, which are in line with the latest advancement of the sustainable approaches, focusing more on the cradle to cradle approach, which can begin at the very nascent stage. For the sixth priority action, and the most important action, is monitoring and implementation of the other actions, in which the companies targeted to making public ESG disclosures on building energy and resource consumption, and to report and track performances against their set targets that they had committed to. So with this, all these priority actions are based on the 3 strategic pillars, which is on capacity building, peer-to-peer learning, and technical research assistance. So with these pillars, we intend to incorporate all the 6 priority actions through series of different activities that were planned throughout the charter. We will shortly send you the link of the charter where you can go through the details of it, where you will be able to understand the activities which are planned as part of capacity building, peer-to-peer learning, and technical research and assistance. So finally, I would like to sum up this entire, what this business charter stands for and what the offer stands for the current signatories and to more signatories that want to get on board with it, is to foster intersegmental conversations between the construction professionals and provide a platform for collaborating, working on decarbonization and net zero targets. This charter also provides an exclusive access to the vendor and manufacturers ecosystem, along with the various other actors which are involved in the building and construction industry, including architects, planner, designer, and engineers. So while raising the bar on decarbonization efforts, through these pillars, specifically through the learning series, capacity building programs, and industry-led peer-to-peer learning activities, all the goals and the priorities listed under the charter can be achieved. And lastly, through this charter, a detailed tracking of all the commitments by the business entities and various other actors which are involved in the building and construction sector can be tracked upon, who are committed towards the net zero or the decarbonization goals in itself. So here, I would like to present that the business charter signatories, we have currently 18 signatories on board. 18 signatories on board, and we are willing to cater to more, and we'll be happy to respond to your queries to join the business charter as and when. So on behalf of all the partners in this journey, which is WRI-India, AEEE, Mahindra Life Spaces, and EcoCollab, I welcome you all to this session, and I pass on this screen to architect Saswati Chetia to begin with her presentation, followed by a conversation with Tanmay Tathagat and Dr. Sunita Purushottam. So Saswati, over to you.
Thank you, Niyati. Yeah, so I will be sharing my screen now. I hope everybody can see my screen.
Yes.
Great. So thanks, Niyati, and thanks to WRI, AEEE, and EcoCollab, and Mahindra Life Spaces. So I'll just start with my presentation, and I'll just switch off my video for the time being.
Sorry to intervene, Saswati. Could you please put it in presentation mode?
Yeah, sure.
Thank you.
Is it in presentation mode for everybody?
Yes, thank you.
Yeah, great. All right. So I assume that since most of you will be, part of the organizations who are co-signees to the charter, and or people who are interested in the subject and are, well aware of the subject that this charter is talking about, So you are all aware of the contribution of buildings to climate change and the need to decarbonize this sector. So when we talk about decarbonization, the ultimate goal for buildings is to go net zero, right? And net zero along the entire life cycle of the building. So what I'll be covering today is climate responsive design. And it has to do with this stage, the operation stage of the entire life cycle of the building. A lot of work, research has gone into this stage. What we talk about energy efficient buildings, climate responsive buildings has to do a lot with how much energy we are using in operating buildings, as a result of that, how much emissions are we emitting while using the building. I think there'll be other sessions on the other, stages, but for today, this is what we are talking about. Now, as I said, a lot of work, research has gone into, energy efficiency of buildings, in making buildings more thermally comfortable, energy efficient. But not only does a lot more need to be done, especially in a country as huge as India, but we also find that that there are many buildings which forego the basic planning and design principles, thinking technology in the later stages of the building construction or operation will make the building efficient. So, and that's the reason why it bears repetition. And that's the reason why we are still talking about climate responsive design, about the design aspects of it. So let's start from, why do we use energy or electricity in buildings? We use it for comfort, for convenience, for productivity, for safety reasons inside the building. And the way we design our buildings impacts some of these aspects of their energy consumption, mainly that of comfort. And not just thermal comfort, but also visual comfort. And there have been many, many studies which tell you that, the greatest amount of energy that is consumed in buildings is to make the building thermally comfortable. That is, either it is used for cooling or it is used for heating. In the Indian context, obviously, cooling is what takes up most of the energy. Now, consider yourself out in the open. This is what we are considering, that's the climate of the location. You're subjected to the temperature, humidity outside, the sun, wind, and rain. And you need to shelter yourself. So you build an envelope around you, an enclosure around you. Now the outside conditions impact this envelope. And the climate outside, that's the ambient conditions, together with the type of envelope that you have built yourself, impacts the inside conditions, which in turn impacts your thermal and your visual comfort. So buildings, and specifically homes, had to be climate responsive till the time we invented technologies for cooling and heating, until we invented technologies for cheap artificial lighting. Before that, there was no other way but to be climate responsive. So what I consider, or I define as climate responsive design is this: design for least possible air conditioning and no artificial lights during the day. And as far as climate responsive design in India is concerned, these are very, basic guidelines which tell you what to do in order to make a climate responsive building in India, which is pretty straightforward. Minimize solar radiation ingress through the windows in summer, minimize heat gains through walls and the roof. And I'm talking for, the majority of India, which requires, cooling most of the year. And in order to do this, that is these two things, minimize solar radiation ingress through windows and minimize heat gains through walls and roof, there are a few things that you need to do. You need to avoid the sun. So you need to orient your buildings properly. You need to shade, you need to insulate, you need to reflect the radiation away from your building surfaces. Then the other thing you need to do, in feasible climates and outdoor conditions, maximize your building's potential to cool via natural ventilation. And how does your building do it? By opening up and ventilating. And the third thing that it needs to do is design for adequate daylight, which is, again, by orienting it right, by avoiding the glare, but including the light that you need, and also by reflecting light inside the space where you require daylight. And the building components or the building design principles or strategies that you need to do are these on the screen. So you need to work on your building and window orientation, your building zoning, internal layouts, wall and roof materials. How do you size windows, window shading, window opening, window material, etc. Right? So we will take all of these like quickly, but one by one. So we are going through the first principle, so to say, which is minimizing solar radiation, minimizing heat gains through windows, walls, and roof. So in India, in summer, the sun moves from the northeastern sky, follows a high path as it travels across the southern sky, and sets in the in the northwest. In winter, the sun again rises from southeast this time, follows a lower path along the southern sky, and sets in the southwest. This is the kind of sun path that is generally followed all across India. A little bit change happens once you go towards the southernmost parts of India, but overall, this is the sun path that is followed. Because of this, the northern facade receives least direct radiation, only in summer mornings and evenings. The south facade is highly exposed in winter, but less in summer. And the east and west facades receive high amount of radiation, both in summer and winter, and the roof receives the greatest intensity. So this already gives you an idea of what needs to be done in order to, how you should build, you should orient your building in order to make it, in order to avoid solar radiation or heat during the summers. Hence, the north and south orientations are preferred orientations with respect to the south. Larger facades, all your windows, basically the glazed windows, habitable spaces, all of them should be ideally located toward the north and south, because on these faces, you get less solar radiation, but good daylight access. East and west facades to be kept small. Now, this is these are some examples I'm giving of, of the principle that we have already spoken of. So this is an example of a site where most building blocks, here, if you can follow my cursor, most building blocks are, the longer faces are towards the north and the south. Obviously, there are certain blocks which are not, aptly oriented. And you will find many sites like this where, you won't be able to orient it north and south. And I'll come to that later. But this is an example of where, of a building in Gandhinagar, an institutional building where you have most of the faces, most of the habitable spaces facing north and south. Here is an example of a site where the design is not able to, orient well with regard to the sun path, if you see. So longer faces facing southwest, northeast, things like that. What do you do in that case? In this case, what you can do is, design the shading in a way in which you can respond to the sun path and, stop the sun from falling on the windows. So this is an example from the same building where, this is the southwest facing windows, where you see that the shading responds in a way in which it ensures that the southwestern sun, the setting sun, is not falling on the glass directly. So which directions you have your windows on, that will influence what kind of shading you will have on those windows. So for example, we already talked about the north and the south facade. The north facade receives least direct radiation, so minimal shading is required, and you get absolutely great glare-free daylight from that side. If you look at a south-facing window, it's easily shaded in summer like this because the sun is very high, and it allows the sun in the winter when you actually want the sun in. Right. So depending upon where your window, which direction your window is facing, you would design your shading accordingly. So this is an example of a north-south this is from the southern facade of the Infosys building. So you see that you have, a chhajja, an overhang over the windows here. And this shades the window well, but at the same time also allows good daylight inside the space. On the eastern and the western sides, you have the low sun, so low altitude angle. Here, vertical shading would be appropriate, but at the same time, the sun also changes position, in reference to the north side, north direction, which we call the solar azimuth angle. It changes between months. So on these two faces, movable shading is best suited. And I will show you some examples of movable vertical shading in the following picture. So this is also once individual housing in South Delhi, where you see that the site is such that you're absolutely not able to orient it properly. You're not able to orient it north-south. So you kind of work with what you have got, and you have all of these movable shading in front of the windows which are facing either southwest or southeast, things like that. So you respond to the climate in that way. You have to give windows, of course, but you ensure that these windows are well shaded at the times when it needs to be shaded. Again, some old examples from old buildings in India. This is from Pondicherry. These are all movable shading. This is from the Butterflies Residence Center in Delhi. Again, a southwest facing window, which was shaded with these cement board panels. And this is a building in Ahmedabad. Safal Profiter again has vertical movable shading in front of it. This is not from India, but I thought, this has chicks on top, in front of it, and quite relatable in our Indian context also. So this is how one would kind of use these shading systems. And the next picture that I have is from Rajkot. You see that, if you don't give shading, provide enough shading, people in Rajkot have kind of, use bed sheets, jugaad karke, they have ensured that, the solar radiation is avoided inside their spaces. So all of them have bed sheets or curtains in front of the windows, not inside the space, but outside the window. So this was about, shading and how you orient your building in a way in which you avoid solar radiation falling on your building. Now let's look at the materials themselves, the wall, roof, and even the window glass materials. So as far as thermal properties of the wall and the roof goes, these are the three properties that are important for us. And the top two ones are the most important ones. The ones which signify the reflectance and emissivity, which is together, it is a property called solar reflective index. And then you have thermal conductivity and transmittance, which signifies the ability to conduct heat. You also have thermal mass, ability to absorb and store heat. But in the context of India, the kind of materials that we are using right now, most of them have kind of, the range of, the specific heat capacities is not varying widely. So in that case, for now, we concentrate on the solar reflective index and the thermal conductivity and transmittance. So the solar reflectance index, basically, the higher solar reflectance index you will have a lower surface temperature. So you would see here that when the air temperature is 37 degrees Celsius, it's just an example. If you have a black surface on your roof, the roof surface temperature goes up to around 60 to 70 degrees Celsius, while a white roof, the surface temperature would be around 40 to 45 degrees Celsius. This would mean that, since the outside surface gets less hot on the white roof, the amount of heat that is conducted inside into the space inside is also less. So, higher the SRI, better it is for the building. So here are some examples of high SRI products. You have high SRI roof tiles, paints, and even the China mosaic finish is something that works very well here. As far as thermal conductivity is the property of the material that depicts how easily heat moves through that material. And we want it to not be easy for heat to move through the material. So we want the conductivity number or the K value to be as low as possible. So here you will see the table shows a few and their thermal conductivities. Building materials, and you will also see that the density of materials that have, or rather, we should look at it the other way around, that thermal conductivity of denser materials tends to be high. And the U value or the thermal transmittance gives the same, depicts the same thing of how easily heat moves through the material, but here we are talking about material assemblies. So K value of the thermal conductivity is talking about one homogeneous material, but a wall or a roof is not made of one thing. There are layers, right? So if it's a brick wall, you will have the brick wall itself, and then you have the plaster inside, outside, and you also have boundary layer of air on both the sides. So when you're talking about non-homogeneous assemblies, wall assemblies or roof assemblies, then the property that you are referring to is the U value. And again, like conductivity or the K value, your U value should be less if you want to, prevent heat from coming inside the space. So here you will see that, from the right side, we also have a lot of monolithic concrete walls coming up nowadays. So the U value of such 150 mm thick concrete wall, sorry, that's a mistake. So 150 mm thick concrete wall is around 3.3 watt per meter square Kelvin. And for conventional brick wall, you have a U value of 2. You get down to hollow clay blocks, it reduces to 1. And of course, with insulation or with AAC blocks, you can get down to like 0.7 and 0.6. Similarly, the roof, you will remember from the previous slide that the roof gets the brunt of the solar radiation. So one thing is to, yes, have light colored finish on top. So basically high SRI, but you also need to insulate the roof. So here are some examples. So you have RCC slab where you're using 50 mm thick puff insulation, or you use foam concrete insulation. There are several other types of insulation that can be used. These are just a couple of examples here. So this is how we are kind of preventing the heat from coming in through the wall and through the roof. Now, of course, you also have heat coming in through the window. So one way is, of course, to put in the windows where they should be. I mean, the appropriate places. For example, as I mentioned earlier, the north and the south sides, and reduce them on the east and west faces. And also shading them. There were various examples that were shown earlier. Other than that, you also have two other properties of the glass used in windows. So you have something called the solar heat gain coefficient, which is a fraction of solar radiation radiated inside through the glass, and thermal conductivity and transmittance of the frames and glass, which is the ability to conduct heat. So you will see here that, single clear glazing has high U value, high SHGC also, and high VLT, which is transmittance of the light component of the solar radiation. What we want is a lower U value, lower SHGC, but a high VLT. So you need to have a balance of all these three properties. As far as SHGC is concerned, the best way to reduce SHGC and the most practical way of reducing SHGC, most cost-effective way of reducing SHGC would be to actually shade the window and not go in for very high performance glass. There is another property for which we do not have standards in India currently, is on air tightness. So normal air movement in and out of buildings, infiltration, exfiltration, which happens, when you have, and this is uncontrolled, infiltration and exfiltration that happens when your windows are not tight enough, when the construction is not good enough. And this through this, a lot of energy consumption increases, because hot air during the summers may come in through your through the cracks, or hot air during the when you are heating a space. For example, in Delhi right now, if you're using a heater, hot air from inside the space may leak out to the cold air outside. So this is also something that leads to a lot of wastage of energy, and this also needs to be reined in. So that was about the solar radiation heat gain part of climate responsive design. The second part was where we are talking about ventilation. And in this statement, I think that what is important here is we are talking about infeasible climates and outdoor conditions. So you don't just open windows anytime for natural ventilation. You open up the windows to maximize the building's potential to cool via natural ventilation. So there are certain conditions that ought to be met to use natural ventilation. You do it when outside temperatures are outside temperatures, in order for the outside breeze to cool your building, it needs to be cooler than the inside of the building, right? So outside temperatures, normally, if they're lower than say 26 to 28 degrees Celsius, that's when you would open up your windows to cool down your building. You won't open your windows during the hot summers in Delhi, because that is not natural ventilation. Then you're just letting the cold, hot air in. But in the evenings, you do want to be able to open up windows. Second condition is healthy outdoors. And that is where, I think a lot has to be said about, how cities are being worked on in terms of climate change. We may talk a lot about natural ventilation, but if we do not maintain the, the city air quality, then, it comes to naught. We cannot do anything about it. Then the third thing is, yes, you may have the windows there, openable windows, but you need to be able to shade the windows properly, because it is a balance between having good ventilation, allowing the wind or the air inside, but you need to cut off the solar radiation. You want to avoid the sun. Then the fourth thing is to have good wind conditions. Of course, if you are, say, in a place like Rajkot or near the coast, ventilation works much better. It's also good that, those are also warm, humid climates, so ventilation works better out there than, say, in a place like a very dense place, dense community or dense development in Delhi, the wind conditions won't be as good. And the fifth thing, and which is very, very important, I think, and something which seems to be, we don't take enough importance of this particular factor, is we need to have operable windows, right? And I will come to that in just a moment. We talked about orientation with respect to the sun, and I just want to put into, get a little bit about the wind direction. So requirements to...
Sorry to interrupt. Yeah, sorry to interrupt. Just wanted to request you to wrap up in the next 5 minutes.
Yes, sure.
Thank you.
So now sun path is constant for a given place, right? But wind direction is unpredictable, and even for a given site, the wind direction and the speed will change depending upon the surroundings and the specific atmospheric conditions. Now, the requirements to manage solar gains and utilize wind may often lead to conflicting results, and one has to strike a balance between these two. And for proper utilization of the wind, usually we say that buildings need to be oriented at an angle to the prevailing wind condition. And in any case, as I mentioned earlier, critical facades and windows should be well shaded to avoid solar radiation from falling on them. Now, the point I was making about, having operable windows. Now, I think what we need to keep in mind is windows need to be openable, but they can be less glazed also. So for example, this window, the second from the left, if you see, this is a window that can open, like almost 90% of the window is openable. But if you look at the amount of glass that is there, it's very less glass here. So this amount of glass is enough for daylight of the space inside, but it doesn't it doesn't allow a lot of glare, but it is still openable. That is, it still is able to bring in enough wind inside, enough air inside. But if you look at these sliding windows here, the 2 pane sliding windows, 50% openable, 3 pane, 66% openable. So I think we should not get, the two things of being openable for natural ventilation and the amount of glass are two separate things, and we need to be able to, like, bring a balance between the two. Last one, design for adequate daylight. And here I will just get into certain three design guidelines that are, basic guidelines for daylight. This first one is also applicable for good natural ventilation, is to have shallow floor plates which provide daylight access to a greater floor area. So building spaces can be zoned to places building spaces can be zoned to the areas requiring more daylight near the perimeter, and the areas requiring less daylight, they can be placed in the center of the floor plate. And few things to keep in mind when designing the windows also in terms of daylight. Daylight penetrates into a room roughly 2.5 times the height of the top of the window from the ground. So the closer the window is to the ceiling, or the higher up the window is, deeper the daylight penetration into the room. And usually we say that the daylight penetration in the room is between 6 meters to 8 meters from the fenestration. And in the best case, if your window height, your room height is around 3 meters or so. And there was this other thing that I mentioned in the daylight is to reflect. So you have light colored light shelves over the windows like this, which help better daylight distribution by reflecting the light off of the light shelf. It is also helped better by having light colored ceilings. And I just wanted to show you the effect or the impact of such changes. So this is an affordable housing project in Rajkot, and where you have around 41 degrees Celsius of ambient temperature outside during the summers. And with a regular, conventional design with brick walls and sliding windows, we had around 38.3 degrees Celsius of summer temperature, of peak temperature inside, with revised window design and AAC blocks, where we also, when we said revised window design, we meant instead of sliding windows, you open up the windows even more, you have casement windows, and reduce the amount of glass. And also with better ventilation and assisted ventilation system, we were able to reduce the inside peak temperature to 33 degrees Celsius. So reduced by 5 degrees Celsius almost. And this also meant that in the whole year, the number of hours which were below 30 degrees Celsius was increased by about 1.5 times. So improved thermal comfort, meaning that people would resort to air conditioners less, or even other, cooling systems less. That means more efficient homes. And this is the last slide, and I just wanted to get into this because we started with net zero buildings, right? So when we talk about net zero buildings, it is obviously there are these 3 steps to it. So first, you minimize your energy requirement. That let's reduce artificial light requirement, let's reduce cooling requirement, right? Then the second step is that whatever energy you do require, whatever appliances you are using or systems you are using, use more efficient systems and operations. And then the last bit is that once you've reduced your energy, requirement to that level by, passive design and efficient systems, then you use on-site renewable energy generation, right? And the closer we get, the more efficient we are able to make our buildings, the less renewable energy we will need, and it will be possible to be completely net zero on site itself and not even procure energy from outside. So energy efficiency and hence climate responsive design is very, very crucial in our efforts to decarbonize and reach what we call net zero buildings. Thanks.
Thank you, Shashwati, for this wonderful presentation and to give a extremely simple yet very technical message on maximizing the energy reduction and also to increase the energy efficiency of building by the very concept of orienting the buildings and how to plan the fenestrations and other kind of opening in terms of shading devices, or even the number of panes in the window that can control the solar radiation and increase the thermal comfort of the building. So thank you for this, for the very simplified information. And I hope that every participant and uh, uh, can put this information to use in practice, and take forward this approach to design of net zero or the climate responsive design forward in their practice. So now I would invite Dr. Sunita Purushottam and architect Tanmay Tathagat to take the conversation forward on introduction to the net zero buildings, and specifically in case of MLDL and approach to net zero in design. Yeah.
Thank you so much. Sashwati, it was amazing that you put everything together very succinctly. I'm audible, I hope, Niyati.
Yes.
Thank you. So there are two of us over here because I have logged in from my mobile as well as...
Stop sharing your screen, maybe. Yeah, thank you.
So I have logged in from my mobile as well as my laptop because of internet issues. So, but nevertheless, this is going to be conversational, and I'm looking forward to this conversation with Tanmay. And so we wanted to explore the business case for decarbonization of the real estate sector. And this would, in the context of net zero, of course. So there are several conversations that Tanmay and I have had, that how do we get more people to embrace green buildings, green practices in the built environment. So with that, I would actually like to start that there is awareness about global warming, and it is generally known that buildings have harmful effect, and in fact 40% of global emissions is attributed to the built environment. And as is the contribution in for India's emission from the built environment. And all of urban India appears to be work in progress with roads, bridges, metros, new buildings, redevelopment activities. They have actually overtaken our urban landscape, leading to air pollution, noise pollution, and rapid loss of tree cover. So Tanmay, what is your view of this rapid accelerated development? And where do green buildings fit in this accelerated development trajectory that we are seeing? Tanmay, over to you.
First of all, thank you. It's a pleasure to be here. And yes, this is a constant debate, this whole issue of rapid urbanization, and is it the cause, is it the root cause, is it of all the problems? I would like to see it in a different perspective. So just like when we talk about emissions globally, we look at the difference in emissions between Western countries and say India, and the huge disparity in per capita consumption and emissions. If we look at India, we clearly have two Indias. And the urbanization and the rapid growth is being fueled by these two separate but interlinked narratives. So there is a need for development, there is a need for more shelter. A large part of what you see in the growth happening in our urban infrastructure and cities is driven by a need to just provide the basic income and minimum standards of comfort to everyone. But at the same time, the other growth or emissions are growing because of this consumption-driven emissions. And again, not necessarily a bad thing if this consumption is leading to, say, higher production or higher quality of life in certain segments, but maybe not. So within India, for example, there's a fantastic study that was done, I think 2019 by India Spend, that looked at our emissions within the country. And you'd find that, our average per capita was something around 0.56 tons per capita or something like that. Uh, but within the country, like Bombay was 3 times, Delhi is 2 times. Uh, the highest in a district is Gurgaon district, which is roughly 4 times the average, and the lowest is district Budh in Orissa, which is zero point 0.2, less than half. So uh, when we have this higher intensity of economic activities in the city, growth, it is driving the prosperity of the country in a way. But the problem is where we get into consumption driven growth, speculative growth, where if we look at the building sector in particular, the higher value of this growth in one way is providing employment, one of the largest employers, construction. At the same time, if you follow the money is not really flowing all the way down. It's a very, very small trickle down that goes down, right? So for us, in a fundamental way, for us to look at this growth and our sustainability, we need to merge these two. There is some amount of uh, growth that is always be required till we reach a point where we're all have a decent standard of living. But we really need to look at this disparity, and in our urban settings, when we look at buildings, urban infrastructure usage, then we need to keep these two in mind. uh, I'll talk a little bit more about it, but it translates into, for example, what kind of buildings need to be built, what kind of infrastructure is required. Do we build for pedestrian or for car? Do we build high rises? Do we build low density affordable housing? Those are decisions that need to be thought from this perspective.
Absolutely, I totally agree with you uh, on these perspectives, because that is what it will make it sustainable development. These questions have to be raised, and not just questions, but have to be brought into the design of all the developments that we are doing. So that will lead us to sustainable development. So wanting to look at, actually, there are two important regulatory updates in December. There was another update from a hydrogen bill perspective, but from the built environment, the December month was really important. We have the net zero bill. India actually submitted its, the at COP27, how it will reach its net zero emission goal in the long term. So there is an updated nationally determined contribution, and it has two broad goals, out of which that India has to actually reduce its emission intensity of the GDP by 45% from 2005 levels by the year 2030. And that one actually has an impact on the intensity target of the built environment. And this brings us to the amendment to the Energy Conservation Bill, which actually puts the Bureau of Energy Efficiency on the driving seat. So it proposes a conservation and sustainable building code for large buildings, and necessitates that renewable energy sources be used at all levels for all infrastructure. So what do you think, how it will mobilize action in the real estate, and what type of actions would we see players across the value chain undertake, which aligns with the above two bills?
So uh, the net zero emissions bill is quite radical. It envisions a way to move forward where the decisions regarding our net zero emissions commitment are taken from a central level to state level down to district level, including uh, identification of issues, uh, developing strategies and solutions, and even funding. And I think
Yes.
it's a fantastic piece of legislation, and I hope that it moves forward. And it shows that, at least in our context, uh, there is an awareness and there is some seriousness about finding a way to move forward. Because for me, that's fundamentally a very big problem when we make these commitments is, we don't even know what they mean. It's very poorly defined. And even if it is defined at a national level, it needs to translate into action at every level, whether it's district or a state or a city. And especially when it comes to real estate, there are many layers to this decision making. So, I would urge everyone to look at this bill and see, it points to a way for us to deal with emissions. It also looks at adaptation, resilience. So, I mean, I have yet to find another bill like this, which is, which is so comprehensive. Of course, a lot depends on how it is implemented, financed, and who controls it. So, in a way, the most positive thing that I find in there is a whole focus on citizen participation and getting inputs from people in decision making, which is a tough thing in a large country like ours. But if it does happen, then you have a way for finding a way to reach net zero without necessarily uh, uh, changing the lifestyle before of millions of people, of looking at the way we can protect our natural resources, which again are closely linked to construction and development. Now, coming to our Energy Conservation Act now, the amendment, yes, it has opened up a few more avenues for Bureau of Energy Efficiency to broaden its presence by expanding energy code to include sustainability, therefore maybe a larger environmental regulation in some way, and also linking a lot of our energy efficiency targets to carbon markets, which is also another interesting way, because it is signaling a more market-based approach to lowering our energy use and intensity. So I feel that the act has the right provisions of enabling more, but uh, you know it still, I think, lacks this uh, a bite. It does not have teeth for really implementation, enforcement, and compliance. And if we look at the building sector uh, all over the world, whether it's the green building movement or the energy codes or standards, they're always driven by regulation, because real estate sector responds to that more than anything else. That that forms the baseline, and consumer demand then takes it further. So all these codes and standards that exist need to be enforced down to the T for every building to have at least the minimum effect. And beyond that, yes, we have our commitments, we have voluntary programs, we have carbon markets that incentivize people to go beyond. But I would really hope that this new amendment allows us to mandate some of these things in a way that they are time bound, they trickle down to every construction project, and with our shift of our definition to include sustainability, we go beyond looking at just the operational energy, but come down to looking at the overall material and the design aspect, because that would be the other two things that are currently not regulated.
Absolutely. And I would like to bring up something controversial over here. So because it's limiting it to a certain type of building, I'm really worried about, all the small bad buildings that will anyway will not be part of this code. So that's the area of concern in my mind currently. The other thing is that if Sashwati touched upon, the adoption of climate responsive design in tune with climate. Okay. The question I have for you is that while CRD needs to be the base of a green home, there are other factors such as water, waste, indoor air quality, materials, natural landscape, and so on. So CRD as a concept, plus all the aspects that we were so well versed with in our earlier architecture, do you think this concept is well understood? But what has the visible shift in building design has been over the years in rapid urbanization, which in your mind may indicate that CRD is almost forgotten, and what needs to be done to bring us back on track?
I would not say that climate responsive design is forgotten, but yeah, you see less and less of it when you go around our mega cities. And yeah, Saswati gave a fantastic overview of what it is. And what struck me the most about her, the way she presented it, was, didn't it almost feel like common sense? Yeah,
Building physics.
yeah.
Yes.
I mean, you don't even need physics, right? I mean, if somebody told you that the sun is on that side and you probably need to shade it, and maybe a bamboo shade or something is the easiest way to do it, or a curtain outside, or if you have a breeze, open your windows and things like that. Maybe there are a few technical advances in terms of materials that maybe have changed the way we could construct, but to say that climate responsive design is forgotten is not right. I think it's overlooked. It's deliberately overlooked. It's such a basic principle of designing anything that, and it is taught in every architecture school. It's a fundamental of every engineering subject. Anyone who's designing mechanical, electrical, plumbing systems. So I feel that as architects and designers, we don't value it much. And it is because, of course, one, there is a globalization of our perspective of what is good architecture or what is a desirable architecture. At the same time, it's also the construction technology and the way our buildings and cities are built has changed, but our the construction techniques, the basic fundamentals that a lot of people here are talking about, simple techniques like ventilators and jalis and screens and spaces that are sunlit and daylit, they have not really moved from a small house or a housing scale to a larger scale, which is sometimes required in the cities. And that's where there's a disconnect, because a builder or a developer or an architect going there really has very little reference. They see vernacular, which is great. Everyone agrees that vernacular is great. They see traditional architecture and techniques which work well, but there is a disconnect between how do you translate it. And that's where some of the work that Saswati showed was great, because it shows basic principles. The same principle of a bamboo jali or a screen can be used in a modern way in a high rise, right? So I really feel that climate responsive design is a fundamental that everyone knows. They just don't know how to express it. And sometimes they overlook it for stylistic reasons, for visual and aesthetic reasons, which they expect their clients to prefer. And the last bit is that some of our regulations related to densities also make it very difficult to use these principles. So suppose I have an FSI of 3 or 4 and I'm making, a 50-story building, and if I look at the carbon footprint, if I have to go net zero of that building, most of it is just in the structure and the elevator and the water pumping that goes in just managing that building. Yes, some of it is going to be cooling and other things. So then how much of it really can you affect? Of course, anything is good, but really some of our basic design patterns of the cities and the choices of densities, high rises, have made it very difficult for these principles to be scaled up. We need an intervention in terms of technology as well there, maybe some new products. So again, if I see the example of what Saswati said, AAC block has been like a boon in that sense. It's a simple replacement for a brick and works well. It has its problems and other things, but similar things, simple things that work in an incremental way are what is required. And to come back to your other point, that smaller buildings that are not regulated by codes and standards, right? They also operate in the same market. So you will find the moment you have a good alternative, like, say good glass was not, a shading or a double glazing or UPVC and others were not really an option for many buildings, smaller buildings, maybe a decade ago. They were mostly used in high rises and other commercial buildings. But, when people started looking at alternatives, that was available in the market, and that became a common thing for people to put even in their smaller buildings and homes. So I find that, it's the same marketplace. If we are able to address the big players and the big developments, the rest will follow naturally. And then eventually, once it becomes a little bit more formalized, it can then be regulated.
Awesome. Yes, you touched upon quite a few points over there, Tanmay. I would like to just pose one last question. I've been asked to wrap up. So when it comes to commercial versus residential, who is leading and what would make the laggers lead?
So energy intensity of our commercial buildings in India is very high. It's amongst the highest in the world because we are in the tough climate and bad designs, bad materials, hardly any insulation, all these things that you see about. So that way there is the success stories and the good examples that we see. There are many, many more in the commercial sector right now, just because they really went a wrong way, in the wrong direction. So now there is some movement. I can see that there is awareness and it's moving. Residential, really, it's more or less been static over the years, right? There's been some innovation, been some good projects. A few cities and states where there are incentives for building green, I find that everyone is going green, at least certified. So for me, that's a positive move. I mean, at least you're not the worst, right? A basic certification or adherence to a standard and some documentation allows people to move, but it's in no way a reason for celebration. I really feel that in the residential sector, because of the nature of the market and the nature of the competition between different developers, unless there is a level playing field in terms of stringent regulation being enforced, we will continue down the same path.
Thank you, Tanmay. So a lot more conversations to be had. And for all the people who are here, I'm not sure whether everybody is has seen the decarbonization charter. It's a request that do take a look, and there will be a lot more such probing conversations which will be exclusively available for people who are signatories, a lot more deeper discussions that as we can all collaboratively move towards decarbonization. So with that, I hand it over to Priyal or Dr. Bhaskar if he's available. So Priyal, over to you. Thank you, Tanmay. Thank you.
Thank you so much, Dr. Sunita and Mr. Tanmay, for this insightful discussion. We have a few questions from the participants, so I will be reading them out, and I'll also request this, maybe the three of you, Shashwati as well, to just turn on your video. So in case you'd like to respond, you could do that. Okay, I'll just, so we have a lot of questions, so I'll have to select them specifically. To begin with, Ravi Reddy has a question. He's asking, is green funding seen to be a burden or a necessity? Can this be addressed from culture point of view in seeing the need of energy for sustenance, something like the thermal energy requirements for running blast furnaces in developed nations against promoted home energy needs by solar panels by underdeveloped countries? Some countries are in disadvantageous position, and he thinks there has to be a global rationale in policy. Any of the speakers can take this up. Tanmay, would you like to go for it?
Yeah, I'm trying to understand the question. Green funding is so in some ways it's a necessity, although you're right. When we talk about green, very often we talk about the incremental cost being zero or even positive in that sense. So you get lower costs with green. So but some amount of funding is required for us to change the way our buildings and infrastructure are built right now and to go to a new trajectory. So, as you know, take an example, if you're talking about, say, cooling, and we know that maybe there is a way to have more insulation and buildings to be, so then insulation needs to be added for the cooling need to go down. And there has to be some investment upfront, which you may recover over a few years. So it is a necessity. I don't think it's a big burden if it is distributed for majority of the people. But yes, for certain segments, for our cities, for our infrastructure, this transition will require certain investments.
Thanks, Tanmay. I'll just see if Shashwati or Dr. Sunita want to add anything to it.
No, I
don't.
not this. Yeah.
Yeah.
Okay, thank you. The next question is from Vishwanath. How can value engineering be applied to designing of net zero buildings?
Shashwati, you want to take up that?
I was just trying to figure out when you were talking about value engineering, because that seems like a very systematic approach to, figuring out, getting a lot of data, understanding where, the problems are and all of that. I'm not sure I'm the right person to answer this question, really. Yes.
So I can take that up. Yeah, I can take that up. I must say that you must not value engineer the net zero design out of the design. So often what happens, of course, there's opportunity to value engineer everything. So if the word value engineering means not doing this, not doing that, changing this, don't do that. Because once you design a net zero building and you have your facade, you can't touch it, right? So value engineering happens right, if it is happening right at the beginning stage and you have designed the facade properly, you have designed your roof to be solar compatible, you have designed your building to be to have the right shading, both horizontal and vertical shading, if you have designed the windows to be right, the opportunities for value engineering would in the construction phase should not touch on design what is already in the facade. So I have had questions around, can we do that? Can we take this out? Can we do that? We shouldn't do that. The other thing is that when it comes to value engineering of materials, what needs to be done upfront in the design stage, that needs to be taken into account. And during the construction phase, all your value engineering efforts must be around how you manufacture, how you construct without wastage. And again, doing it right at the design stage and ensuring that your architect and your projects team are sitting together all the time, as right from design to the execution, a lot of wastage can be avoided. And there are data points saying that, there are 5% of building materials are wasted, 3 to 5% of building materials are wasted. And if you look at it in terms of cost of construction, it could probably run into crores for every project. So these are some of the areas that we need to really look at. So I don't know whether I've answered it, but what you mustn't do is what I'm sharing, because often the word value engineering could mean for the costing team to take things out, and it must not be touched. So once you have a proper design and you have agreed with the architectural team that this project is based on CRD, things must not be taken out at all. Often the sustainability features are taken out or not implemented, and that we need to be wary of that.
Thanks. Thanks for your responses. We have an important question here from Shaurya Patel. One of the complete missing discussions here is the application of net zero concept in affordable housing and informal settlements. How can net zero buildings be made affordable to the population whose incomes are low? Also, what about development of informal settlements and slums? Can we have net zero informal settlements or slums?
Shashwati, want to take that? Shashwati or Tanmay?
I'm just trying to think when you say net zero affordable housing, right? Net zero affordable housing and informal settlements. What I feel is, anyway, when you're talking about informal settlements and affordable housing, their energy consumption is anyway quite less, right? And through climate responsive design or good passive design, what we try and do is that not lead them towards something which a product or a house that really requires them to have an air conditioner or something like that, a cooling system, or maybe switch on their lights during the day. That is something which you can do through climate responsive design. So that's one of the first steps. But when you talk about net zero, you obviously have to kind of compensate for the energy that you are using. So that means clean energy or renewable energy on site, or you are procuring. So yes, there is this whole aspect of of procuring energy from somewhere, clean energy from somewhere. I'm not very sure if there are any policies for that, though I do know that there are certain cities where if for example, Rajkot itself, where affordable housing within the kind of the brief itself, it was there that certain amount of solar panels will be used or installed on the top. It was not enough for it to be net zero, of course, but there are various other reasons. One being that the height of the project itself was not completely as per something that would lend itself to net zero. It was a 7-story building. Probably if they had thought about like 4-story building, it may have. So there are many other things to look at in terms of it being net zero. But I do not know of policies that talk about, that lend themselves specifically for net zero affordable housing or net zero informal settlements. I don't know, Tanmay, if you know of some.
Well, NHB has had, energy efficient housing and especially energy efficient affordable housing as a program. And there are a number of projects that all over the country have been built according to different criteria for being energy efficient. And I think if we look at net zero emissions impact from an affordable housing perspective, then it is probably one of the largest construction demands for the next 10, 20 years. If all of these houses also are badly designed and end up using air conditioning, then it'll also be one of the largest energy end uses for us in the future. And if I look at the current, so we are currently doing a project in one of the states looking at slum rehabilitation and affordable housing. And there was a survey done to look at energy use of these buildings, slum redevelopment buildings, which are high rise. And the overall energy use intensity of the building is 3 times more than the energy use intensity of an individual apartment in that building. So because of the way, we redevelop our informal settlements and affordable housing from low rise, high density to these high rise developments, we are just by fundamental change in design, we are increasing the energy and use intensity even without air conditioning by 3 times. So that question is very pertinent. There has to be an approach of looking at our emissions impact of new informal, affordable, and redevelopment projects, and then reevaluate if we are doing the right thing.
Great. Thanks, Tanmay. And Shashwati, thank you very much. The next question is from Shakir. He's asking how can automation in construction help in reducing carbon footprint in the building and construction sector? Or maybe perhaps generally the role of technology, if you can throw some light upon that.
I think the simple answer would be by, I don't know, reducing wastage probably during construction itself also, and even during operation of the building when you're looking at automation. Because things are more calibrated then. That is one way of looking at it. And automation during construction, if you're also thinking of things like, for example, prefab, materials, structures, things like that, then again, you are reducing a lot of wastage. So a lot of your embodied carbon side, the upfront carbon that is used in constructing the building, also reduces when you are going in for automation that way. That is how I would look at it. But at the same time, again, if I'm looking at the complete cycle of carbon emissions from buildings, automation, yes, I do feel that many people, many organizations also bend a little bit more towards, okay, what can automation do, or what can IoT do, and things like that, which is all very good. And I think people go in for these, just thinking that these terminology, because the terminology sounds very stylish, or on trend. That is an important aspect, because that kind of talks about occupant behavior once the building is completed and things like that. But at the same time, it is important that how the building is built. That is important. What are you building it with, like the type of materials, and communicating to the user what the building is, how the building is efficient. Not just communicating that, oh, you can figure out how much your building is using, or aapke smartphone mein aa jayega this. That is one part of it, but the important part is that also tell your consumer, tell the occupant why their building is more efficient, how is it more efficient, and how they should operate the building, including their windows, including all the different tangible or physical features in their building. So definitely a lot of things that can be done through automation, but there is also the need to make aware of the other parts of the building, really.
Thanks a lot, Shashwati.
Priyal, I have a view on automation, and there are various parts to automation, and Shashwati rightly pointed that it is perhaps more trendy to talk about automation than to talk about sustainability. Both of them are interlinked, and both of them need each other. Okay, so one enables the other if used in the right way. Okay, so automation itself, even if it's a work process automation, say remote monitoring of construction could lead to a lot of efficiency within the building sector. So remote work progress, centrally controlled mechanisms, snag management, then using drones to look at where the progress is happening. These will come up, and these even the the sites are getting monitored using cameras to look at the progress is going to become a necessity. Apart from that, document management, media libraries, these will become more and more, entrenched in this sector with time. And this is, there's no escape for automation. So I'm talking about the construction process itself. But if you begin the land survey process or look at, the flow of water or the surface model and the digital terrain model, all of this is enabled by automation. Many of these are being brought into the play. Often we use third-party tools or websites to look at flood risk or water stress and so on. So there are many different elements, many different digital elements that come in at different stages. Sashwati touched upon the post-occupancy piece, where IoT devices, for understanding the post-occupancy behavior becomes very critical when it comes to even validating claims around net zero. Automation will be there. It is, I won't say integrated to the extent that we want, because a lot of this is innovation and work in progress, but it is going to be there and it's here to stay.
Thank you so much, Dr. Sunita. And we're just slightly over time, and I would like to just wrap up the session now. So once again, thank you very much for the speakers for sharing your valuable thoughts with us and spending time on this, and for taking us through this important discussion of designing buildings in line with the climate goals that we hope to achieve. I would also like to thank all our attendees for joining us and staying till the end. And we're pleased to share that since this is a series, we will be having the next session in February, and we will be communicating more details very soon. And if any of you are interested in knowing more about the Charter, I've pasted the link in the chat box. Please do have a look at it, and please do reach out to any of the partners, and we look forward to connecting with you and having further discussions on that. And yeah, hope you all have a great week. Thank you so much again.